Hi, this is Leetcode question. Add edges to make degrees of all nodes even. This is the third question of weekly contest 324. So you are given a graph, and this graph has n nodes. These nodes are from 1 up to n. So for this graph we have n equal to 5, and so we have 5 nodes, 1, 2, 3, 4, 5. The degree of the node is defined as the number of edges connected to that node. So for example, for this node 4 we have 2 edges, so we have degree equal to. For this node we have 1, 2, 3 edges connected to this node, so the degree is 3. For this node we have 3 edges. For this node we have 1 edges. For this node we have the degree equal to 1. You can add at most 2 additional edges, possibly none, to this graph so that there are no repeated edges and no self loops. So you cannot add node edge between these two nodes because they are already connected, and also you cannot do self loop edge. Return true if it's possible to make the degree of each node in the graph even, otherwise return false. So here we have the degree of this node is even, the degree of this node is odd, this one is odd, this one is odd, this one is odd. So we can add up to 2 edges extra to fix these for odd degrees. What we can do, can add connection between this node and this node, and edge between this node and this node, and by this the degree of this node become 2, the degree of this node become 2, the degree of this node become 4, and the degree of this node become 4. And so all the nodes degrees are even, so we need to return true for this graph, as we managed to make every node degree even using at maximum 2 extra edges. Now here we have also this graph here. This graph has n equal 4 nodes, and the degree of this node is 1, 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 and we can add 2 extra edges like this. The degree of this one become 2, this one 2, this one 2, this one 2. So now all the degrees are even, and so we need to return true for this graph. In the right side we have another graph of n equal 4 also. The degree of this node is 3, for this node is 1, for this node it's 1, for this node it's 1. Now we can connect this node with this node, and the degree of this become 2, with this become 2. Now we need to fix this and this 1 and 2, but they are already connected, so it's not possible to make all the degrees even, and so we need to return false for this graph. Now we have these two graphs. This is of n equal 5. The degree of this node is 2, for this is 3, 3, 2, 1. So we have, this is 4, as we have 4 edges. So we have 2 nodes with odd degree, and we can fix this these 2 nodes by adding 1 edge. So this become 2, and the degree of this node become 4. So all the degrees are even, and we can return true for this graph. In the right side also we have this graph of n equal 2. We have 2 nodes, and the degree of this one is 1, the degree of this one is 1, and they are already connected, so we need to return false. And here we have a graph of n equal 5. The degree of this one is 2, this one is 2, this one is 2, this one is 1, this one is 1. Now we need to fix these 2. These are connected. In this case we can find other node that is not connected with these 2 nodes, and we can add 2 edges. Now this degree become 4, which is even, this become 2, which is even, this 2, which is even, and so for this graph we need to return true. So how can we solve this problem? First of all, we need to build the graph. We can do that by building the adjacent list for graph, in which every node store all the connected nodes to it. So it will be vector of vector. And then we loop over every node and see the size of its vector or of its neighbors, and if it's odd, if the size is odd, we add it to a new vector called odd nodes. This odd nodes will contain the nodes with odd degrees, and in this case we have node 3 or node 1 and node 2, node 3 and node 5. All of these have odd degree. And after we create this vector, we need to check the size, like how many nodes have odd degree. If the number of nodes is greater than 4, that means it's impossible to fix the graph to make every node with degree even, and that's because we can add only 2 edge. Like imagine this node has odd, this node has odd, and this node has odd. So we have 5 nodes. We can use only 2 edge, and this will remain odd. So if the number of nodes or odd nodes greater than 4, we need to return false. This is the first case. The second case, if the number of odd nodes equal 0, then we need to return true, and that's because nothing to be done for the graph, because every node is with even degree. Now the third case is when the number of odd nodes equal 2. For example, this case here, we have this degree equal 1, this is with degree equal 1. So odd nodes vector will contain 2 nodes, 4 and 5, and the size of it equal 2, and in this case we need to check if there is an edge between the two nodes. If there is no edge, we can simply add one edge, and so if there is no edge, we conclude that we can add one edge to fix them, and so we return true for this function, for this case. And here in the right side for this graph also we have two nodes with odd, but there is connection between these two nodes, and so we will return false in this case if there is connection between these two nodes. Now it's possible also that there is connection between the two nodes, as we can see here. Here we have one, here we have one, so these are the only two nodes with odd degrees and they are connected. Now we can check if there is another node that is not connected to both of them. For example, 3 is not connected to 4 and it's not connected to 5. In that case we can add these two edges, and so for this graph we need to return true. So these are the three cases for when the degree or the number of nodes that has odd degree equal to 2. Here we return true, in this case we return true, in this case we return false. Now we said greater than 4 we return false, equal 0 return true, equal 2 we have these three cases. Now for equal 4 we need to check. So for this case we have this 3 and it's here 1 2 3 4, and to handle the case for 4 we will cover all the cases. So for the first node 1 we take 1 and 2 and 3 and 5. We see if this permutation, this pair and this pair, if these are disconnected or there is no edge between these two, and there is no edge between two, we return true. If there is an edge between 1 and 2, then we move to the next case, which is we take 1 with 3 and the second pair will be 2 and 4. Then we check if there is edge between these two nodes and between these two nodes. If both does not have an edge between them, we return true. If any of these pair has an edge between its nodes, so 2 and 4, if they have edge between them, we need to return false. And before returning false, we can check the other pair, which is 1 and 4 and 2 and 3. We can check also this case, so we have 3 cases, and see if there is no edges between the pair, we return true. If there is an edge between any of this, it means this is the last check and we need to return false. So for this graph we check 1 and 2. 1 and 2 there is no edge. 3 and 5 there is edge, so this case failed. We move to the second case. 1 3 it has edge, so it fails. We move to the third case. 1 and 4 they don't, there is no edge between them. 2 and 3 there is no edge between 2 and 3, so it passes, and in this case we return true for this graph. For this graph here we have odd nodes 1 2 3 4. The first pair is 1 2, then 3 4, these are the two pairs. 1 and 2, there is no edge, so we connect them. 3 and 4, there is no edge, so we return true. For this graph in the right, we have 1 2 3 4. So for the first case, 1 2 and 3 4, there is an edge between 1 and 2, so we move to the second case, which is 1 3 and 2 4. There is an edge between 1 and 3, so we move to the last case, which is 1 and 4 2 4. There is an edge between 1 and 4, so we return false for this graph. And by this we covered all the cases. Now for the odd cases, like you cannot create a graph with the number of degrees equal to an odd number, so always the vector must contain an even number, 0 2 or 4 or greater than 4, and we need to cover all the cases. Let's look into the implementation. So first of all, using the edges, we need to build the graph. Then we have this vector of odd nodes that will store the nodes with odd degrees. So we loop over all the nodes from I to n, and if the size of or the number of connected elements is odd, we push it to the odd nodes vector. Now, as we said, if the number of odd nodes is greater than 4, we return false. This is the first case. And if it's 0, we return true. If it's 2, we have many cases here. First of all, we need to check if there is an edge between if there is an edge between the two nodes. So node 1, the first node is n0, the second node is n1. And if there is no connection between the two nodes, like in this graph, we just add the connection, and so we return true in this case if there is no edge. If there is an edge like this or this here, we need to check to see if we can find a node that is not connected to both of them, and if we find that node, we can return true as in this graph. Otherwise, we return a false as in this graph. Now we need to cover for n equal 4. So all these three cases for n equal 4. First of all, we divide it into pairs. We take n0 with n1 and n2 with n3, and we need to check if there is an edge between n0 and n1, and if there is an edge between n2 and n3. If there is no edges between these nodes, we return true. Otherwise, we will take the other permutation, which is or combination, which is n0 with n2 and n1 with n3, and we need to check that if there is an edge, for example, between n0 and n2, we move to the last combination, which is n0 with n3, n1 with n2, and we check. If it failed, we return false.